Hello everyone. In uniform acceleration motion, till now, whatever questions we have solved, those were for the particle moving in horizontal straight line. Now we will consider uniform acceleration motion of a particle in vertical direction. We may have certain situations where objects are either thrown in the upward direction, or those are either thrown or let's say dropped or released in the downward direction. So in that case, we are going to solve such questions by using uniform acceleration motion in vertical direction. We know in uniform acceleration motion, acceleration of the particle remains constant. For vertical motion, the constant acceleration is always taken as acceleration of gravity, which is always 9.81 meter per second square. And remember, the acceleration of gravity is always in vertically downward direction. It doesn't matter whether the object is moving vertically upward or vertically downward, the acceleration of gravity is always acting in the downward direction. So that is one very particular thing we need to remember all the time while solving these numericals. But for the objects which are mechanized, or those are motor operated, let's say objects like elevators or lifts which are operated by motors, generally in those cases acceleration is not considered because of gravity. While solving the numericals, we are going to have both these situations, object either going upward or in the downward, vertically downward. So we have to follow certain sign convention. Whenever the object is moving vertically upward, we are always going to consider the acceleration of gravity g negative. We know that acceleration of gravity is always downward. So if in the opposite direction of the gravity, the motion of the object is there, that is in the upward, acceleration of gravity is going to be taken negative. Whereas if direction of the motion of the object and the direction of acceleration of gravity, if both are the same, let's say, of course, if gravity and the motion of the particle both are in the downward direction, acceleration of gravity is always downward. So in the same direction, if the object is moving, acceleration of gravity should be taken positive. To solve numericals of vertical uniform acceleration motion, we are going to use the same three equations of uniform acceleration motion, those we have used earlier. Namely, v is equals to u plus at, s equals to ut plus half at square, and the third one, v square equals to u square plus 2as. Only in case of the constant acceleration a, instead of a, we are going to use g in all the given three cases. Now let's begin with numericals. Let's consider this question. A ball is projected vertically upward with velocity of 9.81 meter per second. Determine the maximum height traveled by the ball, the velocity at which it strikes the ground, and total time of journey. So here the given situation is explained with the help of this sketch where we have shown the ball is thrown from the ground level with velocity 9.81 and it reaches certain maximum height, and that maximum height point is B. Now always remember, whenever we are throwing the object vertically upward, because it is always being pulled by the acceleration of gravity in the downward direction, as the object goes up and up, its velocity goes on decreasing, and at the highest point its velocity becomes zero. So that is the general observation. We have to use it everywhere in vertical acceleration motion. So at point B, which is the maximum height point for the given ball, velocity is going to be zero. Our aim is to find out how much is that maximum height where the velocity is going to become zero, and what is the total time of travel for the given ball, that is starting from A to B and then while coming back from B to A. Actually, that time from A to B and B to A both are going to be the same. We will prove it meanwhile solving the given question further. And apart from that, we have to also find out with what velocity it strikes the ground. Again, remember, if we are throwing any object vertically upward from a point, it will go at the highest point, its velocity will become zero, and it will come back when it reaches the same point from where it has been thrown, its velocity at that point is going to be exactly the same that we had maintained while throwing it up. This is also a general observation, but here again let's try to prove it while solving the question itself. Right, so consider the motion of the ball from A to B, from ground to reach the maximum height point, and considering the uniform acceleration motion with the given data, because we are looking for the distance traveled vertically upward, let's use the equation v square equals to u square plus 2as, where final velocity v is 0, that we know at point B. Initial velocity is given to us at point A, 9.81 meter per second. A is the acceleration of gravity and s is nothing but the distance traveled from A to B. Now because object is moving up, the acceleration of gravity g we are going to take negative, right? So that we have mentioned over here. As far as possible, while solving numericals of vertical acceleration motion, whether you are taking a g positive or negative, make a habit of explaining it, why you are taking it negative or positive. In the given equation, we are going to substitute these values, known values, and we are going to end up with the calculated answer of the height reached by the ball from point A to B. So that comes out 4.905 meter. You can check the calculation part. Further, we have to find out time of travel from point A to B, and for that we are using the equation final velocity v is equals to initial velocity u plus acceleration into time of travel. Again, for the motion A to B, which is vertically upward, let's take acceleration as minus g and substitute the values. That will give you the time of travel from A to B as 1 second. Further, because we want to calculate the total time of travel from A to B and B to A, now let's consider the reverse motion of the ball from maximum height point to the ground while it's returning. And now of course, while returning back to the ground, it has to travel the same height h. So now we don't have to prove that, because it is a let's say it's an obvious thing that if it has traveled while going vertically upward distance h, the same vertical distance h will be traveled while coming in the downward direction. So that we already know. Using that information for finding out now the velocity, the final velocity when it strikes the ground, let's use the equation v square equals to u square plus 2as. We are considering now downward motion. Remember, acceleration of gravity is always downward. If the object is moving down, take that acceleration of gravity positive. Using that, velocity with which the ball is going to strike the ground comes out 9.81 meter per second. Using this velocity now, further, if I use the equation v equals to u plus at, I can calculate the time of travel to reach the ball to the ground from the maximum height point, of course. So using that equation, the time of travel from A to B comes out again 1 second. So if we have to calculate the total time of travel from A to B and then B to A, let's add up both these times from A to B and B to A. Both are 1 second each, so the total time of travel comes out 2 seconds, and that is again one of our answers. So we have calculated all the required things. How much is the maximum height reached by the ball, which we have calculated as 4.905 meters. Velocity with which it is going to strike the ground is the same velocity with which it has started moving from the ground, 9.81 meter per second, and the total time of journey is 2 seconds. We'll solve 1 or 2 more questions based on this vertical acceleration motion in the next class. Thank you.